18 billion kilometers away, a machine older than most of us just sent home a single number. It wasn't a photograph, it wasn't an alarm, just a faint radio whisper, and it quietly rewrote what we thought we knew about the edge of our solar system. It is 1977. 2 spacecraft leave Earth, weeks apart, each carrying a golden record etched with the sounds of our planet, in case anyone, anywhere, ever found them. Their mission was modest by design: fly past Jupiter and Saturn, take some photographs, gather what data they could, and complete a tour that engineers expected to last perhaps 4 years. Nearly 50 years later, Voyager 2 is still flying, still listening, still further from home than any human-made object besides its twin. It became the only spacecraft ever to visit all 4 giant planets, Jupiter, Saturn, Uranus, and Neptune, using each one's gravity like a slingshot to fling itself deeper into the dark. And when the last planet fell behind it, Voyager 2 did not stop. It kept going, past the outer reaches anyone had planned for, toward a boundary that, at the time, existed only in theory. That boundary has a name: the heliosphere. Imagine our sun not simply as a source of light, but as a wind, a ceaseless outward breath of charged particles, streaming in every direction at over 1 million miles an hour. This solar wind inflates a vast bubble around our entire solar system, a bubble that shields the planets, including the one you are standing on right now, from much of the radiation that fills the rest of the galaxy. For most of human history, we lived entirely inside that bubble without even knowing it was there. We assumed the space around us was simply space, uniform, anonymous, the same everywhere. It took a spacecraft physically crossing the boundary to prove otherwise. Voyager 1 made that crossing first, in 2012. Voyager 2 followed in 2018, becoming only the second emissary our species has ever sent beyond the sun's influence and into true interstellar space, the vast, cold ocean between the stars. And it is what happened in the years since that crossing that has produced Voyager 2's most important discovery yet. Here is the discovery, plainly stated. The longer Voyager 2 listens to interstellar space, the more it reveals that this region is nothing like the calm, empty void we once imagined. Its plasma wave instrument, built to sense the faintest oscillations in charged particles drifting through the dark, has picked up a phenomenon nobody fully predicted: spontaneous, recurring oscillations in the plasma surrounding the spacecraft, rippling outward like waves crossing the surface of a still pond after a stone has broken it. Scientists have learned to read these ripples almost like a heartbeat, a signature of density rising and falling as material shifts in the space around Voyager. What causes them? In many cases, the disturbances trace back to violent eruptions on the sun itself, vast explosions of solar material that took more than a year to cross the unimaginable distance between our star and the spacecraft. When that shockwave finally arrives, it disturbs the surrounding plasma, and Voyager 2 feels it, faithfully recording the disturbance and transmitting it home across 19 hours of radio silence. It is a strange kind of intimacy. A star sneezes, and 18 billion kilometers away, a 45-year-old machine notices. But plasma waves are only one part of the story. Voyager 2's magnetometer, sensitive to magnetic fields 1 billion times fainter than the one that turns a compass needle on Earth, has revealed something equally surprising about the structure of interstellar space itself. Before Voyager arrived, the prevailing model imagined the magnetic field beyond our solar system as relatively smooth and orderly, gently bent by the heliosphere pushing against it. Instead, Voyager 2 found a field that is twisted, layered, and far more turbulent than predicted. Magnetic field lines from inside our solar bubble appear to align unexpectedly with magnetic field lines outside it, suggesting that our solar system does not simply collide with the galaxy around it, but connects to it, exchanging structure and energy across a boundary that is far more porous than anyone anticipated. This single observation, confirmed and refined as new data continues to arrive, has forced researchers to reconsider not just what the edge of our solar system looks like, but how connected we truly are to the wider galactic environment around us. And then there is the matter of cosmic rays, high-energy particles born in the deaths of stars, the violence of supernovae, the unimaginable engines of distant black holes. Inside the heliosphere, the sun's magnetic field acts as a shield, deflecting many of these particles before they ever reach the inner solar system. The moment Voyager 2 crossed into interstellar space, its instruments recorded cosmic ray intensity surging dramatically, confirming directly what theorists had long suspected. The bubble our sun creates is a genuine sanctuary, sparing the inner solar system from a far harsher radiation environment that fills most of the galaxy. Newer data, gathered continuously in the years since that crossing, has allowed scientists to map how this radiation fluctuates over time, tracking it against the sun's own 11-year cycle of activity, and revealing that our solar bubble itself swells and contracts like something almost alive, breathing in rhythm with the star at its center. None of this arrived in a single dramatic instant. That is, perhaps, the most important thing to understand about Voyager 2's biggest discovery. It was not a sudden flash of insight. It was built slowly, the way the deepest truths in science usually are, one data point compared against another, one year of measurements layered onto the next, until a picture began to emerge that no single observation could have revealed on its own. Only by listening patiently, year after year, did scientists begin to see the heliosphere not as a static boundary, but as a living structure, asymmetrical, dynamic, magnetically entangled with the galaxy beyond it, and constantly reshaped by the breathing rhythm of our own sun. Consider for a moment the distance involved. Light takes only 8 minutes to travel from the sun to Earth. It takes more than 19 hours to reach Voyager 2. Send the spacecraft a question today, and you will wait nearly 2 full days simply to receive a reply sent by a transmitter so faint, so far past its intended lifespan, that engineers consider every successful transmission something close to a small miracle. Voyager 2's power source, a block of slowly decaying plutonium, loses strength every single year. One by one, its instruments have been switched off to conserve what little power remains, the way a homeowner might turn off lights in rooms no longer needed, hoping to keep the essential ones burning just a little longer. And still, against every reasonable expectation, it continues to speak. There is something quietly extraordinary in that persistence. A machine built with less computing power than a modern calculator, traveling farther from home than anything else humanity has ever built, continues, even now, to make discoveries no Earth-based telescope could make in its place. Not because it is searching for anything dramatic, but because it is simply there, in a place nothing else has ever been, faithfully recording what it finds. We sent 2 small ambassadors into the dark 47 years ago, hoping only that they might survive long enough to photograph a handful of distant worlds. They did far more than that. They became our only witnesses to the true edge of the sun's domain, and in doing so, revealed that the boundary of our own solar system is stranger, more dynamic, and more deeply connected to the galaxy than we ever dared assume. Somewhere out past the planets, past the long shadow of our sun's protection, a single spacecraft continues to drift outward into the silence between the stars, and as it goes, it keeps reminding us of something worth remembering. The universe does not stop revealing itself simply because we stop looking. It only waits for something patient enough and far enough away to listen.